Greetings to all of you. The session is going to cover the section of intermediate chemistry. Will be fetching for your international entrance and the competitive exams as well. India is conducting JEE Advanced. JEE means examination that will give the admission into IIT and NIT stream. All across India, there will be an exam called a NEET, that is the entrance into medical stream. Medical entrance exam will be conducted once in a year. In addition, Telangana and Andhra Pradesh government are conducting MSET examination for the admission into BTech stream that will be a technical domain. There also the kind of session what we are discussing is very much helpful. In addition to all this, competitive exams will be conducted with the various state and the central organizations to get the job opportunities into the government sector, where general studies common question paper is available, then general science content will be there inside. The session we are discussing is very much fetching in that direction as well. Let's enter into our today's session. The question one is going to cover the Nobel Prize in the field of chemistry for the year 2001, which is given to jointly given to William S. Knowles and Royce Noyri for their work in the chirality catalyzed hydrogenation reaction. This is related with the stereochemistry. And other half to K. Barry Sharpless. Sharpless epoxidation, most familiar reaction everybody aware about. So that kind of Barry Sharpless for his work on chirality catalyzed by oxidation reactions. This is the way the Nobel Prize for the year 2001 in the field of chemistry was accorded to these many scientists together. Let's see their brief info regarding that. William S. Knowles contributed for the Nobel Prize for the year 2001. Royce Noyri also contributed Nobel Prize because of their work on chirally catalyzed hydrogenation reaction. Barry Sharpless is another scientist who also accorded for the Nobel Prize, contributed 1/2 for again optically active chirally catalyzed oxidation reactions. Let's see their info regarding this. These scientists. The Royal Swedish Academy of Sciences has decided to award the Nobel Prize. This is a esteemed prize, a world recognized one, and in the field of chemistry for the year 2001 for the development of catalytic asymmetric synthesis, with one half jointly given to these many scientists: William S. Knowles, St. Louis, Missouri, United States of America; Royce Noyri, Nagoya University, Chikusa, Nagoya, Japan, he belongs to. These together worked upon their work on the chirally catalyzed hydrogenation reactions. They worked on chirally catalyzed hydrogenation. Hydrogenation is alternatively named as a reduction process. And also to K. Barry Sharpless, the Scripps Research Institute, La Jolla, California, United States of America. So for his work on chirality, catalyzed oxidation reaction, Sharpless is well known for his epoxidation process. Most of the synthetic application we can go with. So that kind of chirally catalyzed oxidation reactions was developed by this K. Barry Sharpless. So that this is about the brief info regarding 2001 Nobel Prize laureates in the field of chemistry. Now let's see what kind of research is accorded with this Nobel Prize for the year 2001. What is the contribution of their research? Many molecular appears in two forms, their mirror images, just as our hands mirror to each other. Such molecules are called chiral. In nature, one of these forms is often dominant. So in our cells, one of these mirror images of molecules are like a globe. Okay. Everybody aware that what will be the mirror image. If you see your face in the mirror, what happens? Its image will appear there. And the same way, naturally, one of your hand is a mirror image of another one as well. In the same way, in stereochemistry also you can find such mirror images over there. And these kind of mirror images, when found, they are optically active in nature. They might be enantiomers or diastereomers. That kind of mirror images, though present, one of the isomer will be dominated. One of the isomer will be existed and finds the maximum extent of application among those two. in contrast to other on which may even harmful, right? Pharmaceutical products often consist of chiral molecules, and the difference between the two forms can be matter of the life and death, right? So one of the isomer gives the prominent applications for the living organisms, one may not give. That's the reason why whenever mixture of optical isomers got generated, two mirror images got generated, we need to screen out their activity, so that which is more potent towards the activity we need to trace out, and we need to go for its application part, so that that part chirality plays a matter a lot, being chiral molecules all are not having even extent of biological activity, so that whichever having highest tendency to give the application without causing any harmful impact, so that that isomer to be traced out, that to be collected, and can be implemented for the further pharmaceutical applications, as was the case, for example, thalidomide disaster in 1960s. This is why vital to be able to produce two chiral forms separately. Though we are generating chiral forms, a mixture of chiral compounds are generated. Those should be taken separately. Those should be separated before application in the pharmacopoeia, because two chiral auxiliaries may not have the equal extent of their applicability. That's the reason why both should be treated, both should be applied separately. This year's Nobel laureates in the chemistry have developed molecules that can catalyze important reactions, so that only one of the two mirror image forms are produced. This is called stereoselectivity. Which isomer your tends to generate, that isomer only selectively generated rather than mixture of both the products. If you are generating mixture of products, what happens? For example, both are generated 50-50. What happens? 50% a useful product, the remaining 50% may not be applied, so that we are descending, we are decreasing the yield of the product, not up to the level, right? So that the scientist mainly focused on that stereoselectivity. Stereoselectivity means which isomer having high potency, which isomer is tend to be generate high pharmacopoeia impact, that isomer to be generated in the maximum yield without generating the either byproduct, or else any mixture of products can be avoided. Okay, the catalyst molecule which itself is a chiral. Whenever chiral catalyst was chosen, then only we can go with that stereoselectivity. Speeds up the reaction without being consumed. Being catalyst is not consumed in the reaction can accelerate rate of the reaction maximum extent, and which in turn generate the higher yield in comparison to without catalyst application. Just one of these molecules can produce millions of molecules desired mirror images form. Okay, single catalyst can initiate and propagate the chain of the reaction, so that we will go with the millions of molecules to be generated by this what catalysis? A chiral catalysis process. William S. Noyes discovered that it is possible to use transition metal to make the chiral catalyst for an important type of reaction called hydrogenation. Being hydrogenation is tends to adding hydrogen to any molecule in the presence of the metal catalyst, so that this William S. Noyes developed a unique pathway where he traced out the transition metal in order to synthesize the chiral catalyst, and that they used to perform the hydrogenation process, thereby obtaining the desired mirror image, whatever we require. So two are possible, but among two, one to be generated, that to be focused in order to synthesize that. One of the mirror image is desired mirror image is generated in the maximum extent as the final product. His research quickly led to the industrial process for the production of levodopa. Levodopa is the important drug auxiliary which used for the treatment and the curation of Parkinson disease. This is a kind of neurological disorder. Rise in Oiri has led to the further development of this process, today's general chiral catalysis for hydrogenation. This William S. Noyles developed levodopa, which in turn used for the application part of view, that is Parkinson disease curation is possible. And the same methodology was extended by Royce Noyri scientists, and so many kind of other chiral auxiliaries are generated and find their own application in the field of pharmacopoeia. So that together they are considered for the 2001 Nobel Prize. And another part of this Nobel Prize, K. Barry Sharpless, on the other hand, is awarded half of the prize for developing chiral catalyst for another important type of reaction called oxidation. They focused upon hydrogenation, simply said to be reduction, and Barry Sharpless focused on oxidation, but he also gone with that chiral catalysis process as well. Path remains same. The laureates have opened up a completely new field of research in which it is possible to synthesize molecules, materials with the new properties. Obviously, any new compound is getting into the research platform. That new compound will have its own way of properties, so that new properties will be introduced into the research platform by the kind of extensive research carried by the William S. Nobles, and in there is about Royce Noyri and K. Barry Sharpless. They worked upon this chiral catalysis process. These two together worked on hydrogenation. Sharpless worked on oxidation. Most of the people aware about Sharpless epoxidation. It is the extensively applied epoxide synthesis process, kind of oxygen insertion. Today, results of these basic research are being used in the number of industrial synthesis of pharmaceutical products such as antibiotics, anti-inflammatory, and heart medicines as well. Right, so many kind of curatives are available, and moreover, they focused upon the curatives like antibiotic inflammation or reducing inflammations are treated like that, and heart disease is also cured. This is the way the medicines got synthesized by these scientists. A new way of drug synthesis got introduced by these scientists. Hence, they got accorded with the esteemed Nobel Prize for their outstanding contribution in the research of chiral catalysis process. Let's move on to another question collected from the Cambridge Assessment International Education. Here is the simple reaction provided. The word equation is provided. Equation. Chemical reactions can be mentioned either in the form of molecular formula, empirical formula, or word formula. So many representations are possible. This is the preliminary method in order to represent a chemical equation in a word formula. So here the starting materials are taken are ethanoic acid. Ethanoic acid IUPAC name is alkanoic acid. Simply we can say carboxylic acid. Ethanoic acid react like a typical acid. In the organic chemistry, carboxylic acids are the strongest. But in general, in comparison to the mineral acids, we can say it is a mild acid. Okay, overall consideration, it will be mild, but in the field of organic chemistry, it is the strongest acid. Okay, so it is the typical acid. It is the category of the acid. Complete the word equation for the reaction of ethanoic acid with the sodium carbonate. Ethanoic acid is nothing but acetic acid, we can say. So, ethanoic acid is the IUPAC name. IUPAC stands for International Union for Pure and Applied Chemistry. Being it is the acid, can obviously go with the reaction with the base. Sodium carbonate is the kind of base, so that we will get one of the salt, water, and another product is also generated, that is called carbon dioxide. Carbon dioxide gas is also evolved. Generally, whenever acid base got combined, salt and water are the expected products. But in addition, we are encapsulating one of the gas. So in addition to these products, salt and water, carbon dioxide gas is also evolved. Let's see the entire equation. Ethanoic acid is mentioned with the 2 carbon with the carboxylic acid functional group over there. A sodium carbonate is mentioned like this, and there is a formation of CH3 COONA. This is a salt of acetic acid, sodium ethoxide, sodium uh, carbo, sodium ethanoate, we can say. IUPAC name is given as sodium ethanoate. Uh, Sodium acetate. In general, we can say sodium acetate. In addition to this salt, we will get water, being acid base combination giving rise to the salt and water. So that water is the expected product over there. And in addition, or when the sodium is combining, leftover will be the carbonate part, will evolve this carbon dioxide gas over there. This is the way the expected products are sodium ethanoate, water and carbon dioxide, so that we can fill up remaining two vacant boxes with the one is carbon dioxide gas, in either is about water. So water and carbon dioxide filled in these empty boxes like this, so that the balanced equation is mentioned. Two coefficient was taken for ethanoic acid. Why? Because here we are having two sodium atoms. In order to make the salt, two sodium compatiated with the two acetates. So two acetates required to be taken, 2 moles of acetic acid. So 2 moles of sodium acetate formed in addition to the 1 mole of water, carbon dioxide as well. This is the way complete equation is provided. Question 2 got concluded. Let's move on to the another question, that is question number 3. Question number 3 is collected from JEE Advanced 2015 paper 1 question paper conducted by the National Testing Agency. The question is, among the triatomic molecules or else ions, let me mention beryllium dichloride. This is called azide ion, and N2O is called nitrous oxide. NO2 positive nitronium ion will be there, and O3 is called ozone. SaCl2, SOCl2 is called thionyl chloride. SaCl2 sulfur dichloride. ICl2 minus, it is the interhalogen halide. I3 minus, again it is the kind of molecular iodide ion, and xenon difluoride. So among all the noble gases, exceptionally xenon able to give the halides and oxides only, right? So noble gases are inert, but xenon able to react. In its reactivity, only the possibility with the highly electronegative two elements only. One is with fluorine and other is with oxygen, right? So xenon difluoride. These many molecules, let me count: 1, 2, 3, 4, 5, 6, 7, 8. 8 molecules are provided. The total number of linear molecules. So among all total number of linear molecules or as ions, where hybridization of the central atom does not have contribution of d orbitals. Without a d orbital contribution, how many atoms are having linear geometry to be depicted? Sulfur with atomic number 16, chlorine with atomic number 17, iodine with 53, and xenon with 54. This is the way question is given. Among all, the requisite answer is beryllium dichloride, N3 minus and N2O. N2O is called nitrous oxide, NO2 positive nitrosonium cation, N3 minus called azide anion, BCl2 is called beryllium dichloride. All these are existing in a linear form, so that we may count four molecules or ions are exhibiting this one, right? Whereas ozone is a bent molecule and SaCl2 is a kind of sp3 hybridization molecule. This is the way we can sort out all the things. And we entered into the question number 4. Again, it is collected from 2015 JEE Advanced question paper paper 1 question. It is conducted by the National Testing Agency. Not considering the electronic spin, the degeneracy of the second excited state N is equal to 3 of hydrogen atom is 9, while the degeneracy of second excited state of H minus is, okay. Here, hydrogen simplest atom in the second excited state, its degeneracy will be 9. If H minus was taken into the consideration, what is the degeneracy in the second excited state? That to be answered. In order to answer that one, the answer is expected to be 3. Let me explain in a clear manner. Energy order of orbitals of hydrogen is decided by only principal quantum number. Principal quantum number is denoted with n. N gives rise to the energy and the size of the orbitals. Okay. So H minus is decided by, while energy order of H minus is decided by n plus L value. So n plus L value can be taken into the consideration. H hydrogen is retained by only one electron, but if H minus is termed as a hydride anion. H minus is called a hydride anion whose electronic configuration is 1s2. Its energy order is decided by N plus L rule. H minus is having only 1s2 electronic configuration, 2s0 is there, 2p0 is there. If you observe H minus, 1s orbital is resided with 2 electrons and 2s orbital is vacant, 2p orbital is also vacant. 2s is said to be first excited state, 2p is called the second excited state. They are saying that these s electrons are supposed to be excited into second excited level. When electrons are excited to the second excited level, what is the degeneracy of p orbitals? P orbitals are triply degenerated, so that we can say it's a second excited state. 2p orbitals degeneracy will be 3. This is the way we can answer. The H minus is having the second excited state, the degeneracy will be 3. For question number 4, correct answer is 3. We entered into the question number 5, which is collected from the Telangana MCET examination conducted in the year 2020. Which of the following molecule is not paramagnetic in nature? ఈ క్రింది అణువులలో దేనికి పారయస్కాంత స్వభావం లేదు, right? Which of the following is not paramagnetic in nature? Okay. So in order to explain that one, we have to go for molecular orbital theory. Molecular orbital theory suitably explains the magnetic nature and bond order of the given compounds. Bond length is also decided by that MOT theory only. So if we apply MOT theory to all these all these molecules and ions, so that we can depict which is not a paramagnetic one. The criteria for the paramagnetism will be, if electrons are paired up, then we can say diamagnetic. Electrons are spin parallel, that will be a paramagnetic in nature. Oxygen is a diatomic in nature and a paramagnetic. Everybody aware about that one. How can we say? Being one is electrons are distributed, sigma 1 is, sigma star 1 is, 2s orbitals are distributed, sigma 2s, sigma star 2s. 2p electrons. How many 2p electrons are there in the oxygen? 4 contributed by one oxygen atom. And another oxygen also contributing 4, so that 8 electrons. 8 electrons are distributed in the molecular orbital, sigma 2px 2 electrons, pi 2py 2 electrons, pi 2pz 2 electrons. Pi star 2py 1 electron, pi star 2pz 1 electron. So that 8 electrons, how can we count? 2 plus 2, 4, 6, 7, 8. 8 electrons are like this and 2 electrons are spin parallel. Whenever spin parallel electron existed, that is said to be paramagnetic in nature. This is called paramagnetic in nature. This is the way we can go with magnetic nature of molecule oxygen. Go with in either O2 positive. O2 positive means what we have to do? One of the electron from the oxygen to be removed. Whenever one of the electron is removed, only one electron left with the spin parallel. Okay, so here one of the oxygen is contributing 3 electrons, another oxygen is contributing 4 electrons. Total electron contribution is 7 at that condition. 2 plus 2, 4, 4 plus 2, 6, 6 plus 1, 7 electron count will be there. Whenever 7 electron count will be there, one of the electron is absent, but still, due to the existence of this odd electron, it is also the part of what? Paramagnetic. We can say this is also the part of paramagnetic. So we can say O2 positive is a paramagnetic in nature. And another condition you can go with O2 minus. O2 minus means what to be done? Oxygen molecule is given with extra electron. Whenever oxygen given with extra electron, here 5 electrons resided on one oxygen atom, 4 electrons on the second oxygen atom. 5 plus 4, it is said to be how many? 9 electrons will be there. At that condition, 2 plus 2, 4 plus 2, 6, 7, 8, and 9 electrons are resided like this. Molecular oxygen is gaining one more electron. This blue color electron is symbolizing addition of electron by this negative charge. Then if you're going to observe its magnetic nature, these are spin paired electrons. This pi star 2px is a spin paired one, but pi star 2py is having spin parallel electron. Whenever spin parallel electron is there, that is said to be what? Paramagnetic in nature. So that this spin parallel electron is a paramagnetic in nature. O2 minus is paramagnetic. The condition we require to be answered is diamagnetic, which is not a paramagnetic to be answered. That is O2 minus 2. O2 minus 2 is collected from two oxygens which are having two extra electrons. Whenever two extra electrons are given to two odd electrons, all the electrons got paired up. When all the electrons got paired up, what happens? Spin paired electrons are diamagnetic in nature, which is not a paramagnetic. So this O2 minus 2 is designated as a peroxide. So this peroxide is having all spin paired electrons, so that it is not the part of paramagnetic nature. So ఈ క్రింది అణువులలో దేనికి పారాయస్కాంత స్వభావం లేదు. That will be O2 minus 2. O2 minus 2 is the peroxide anion. Option 4 is the correct answer for question number 5. And we entered into the last question of the session, that is question number 6. This is a graphical representation between the pressure, volume, temperature, volume graphs. So they are related with the fundamental laws called Charles law and Boyle's law. Identify the correct observation with respect to the given graphs. క్రింద ఇవ్వబడిన గ్రాఫ్ల ఆధారంగా ఖచ్చితమైన పరిశీలనలను గుర్తించండి. According to this graph, we have to identify what could be the correct relation between the pressure volume, volume temperature, and pressure temperature as well. There is a relation. T2 temperature will be higher in comparison to T1, and P1 will be higher in comparison to P2 is the expected answer, right? So T2 is the final temperature, T1 is the initial temperature, P1 is the initial pressure, P2 is the final pressure. So the T2 greater than T1, P1 greater than P2 is the correct answer. In order to explain this one, we have to go with Boyle's law and Charles law. Boyle's law, what Boyle's law will say? Boyle's law says that volume always reciprocal of its pressure, means volume is inversely proportional to the pressure. Then at the same time, Charles law states that volume is a direct proportionality with the temperature at constant pressure. Pressure to be fixed. In a Boyle's law, temperature should be fixed. In a Charles law, pressure should be fixed. Volume is inversely proportional to pressure is called Boyle's law. Volume is directly proportional to temperature is called Charles law. When we are observing these two, being volume and temperature direct proportionality, as the temperature increases, pressure decreases, because if volume temperature are direct proportional, temperature and pressure indirectly proportional again, so that T2 is greater than T1, and for the given temperature, as V is more, so if volume is more, what happens? If volume increases, temperature also increases, right? So the T2 will be higher in comparison to the T1. Then P will be less. So whenever volume is more, pressure is inversely proportional. So the pressure will be decreased. So we have to write it as P1 is greater than P2. Final pressure will be less. So that final temperature will be higher compared to initial temperature, and initial pressure is higher than final pressure. This is the way we can explain that graph which is mentioned in the option number 2. This is purely based on the Boyle's and Charles law, fundamental laws, right? So by this, we entirely concluded the session. We covered with the various sections of the chemistry. Various domains got covered over here, and the session is really informative and authentic source Databases are visited in order to collect the requisite answers and the relevant information for these questions, which already repeated so many times in the various competitive examinations. Those questions got collected and a clear-cut explanation is provided over here. Hence, I'm sincerely requesting to like the channel. In order to comment here, we have a question for the session. In case of concentration, what is the formula for molarity? What is the formula for molality? So how can we differentiate molarity from molality? That to be mentioned in the comment box. A very simple question it will be. And share with aspirants who are curious about the examination, very seriously preparing for the exams. Subscribe the channel. Definitely we will get more valuable information, valuable content in the near future. Thank you very much for all of you for watching the entire session very patiently. Thank you one and all.